Greetings everyone. This video is going to be a short tutorial on using advanced post-processing features inside Paraview. So let's jump right in. I'll open a sample result data, and here we got our block here, and we are going to apply some forces on these surface patches. And so let's look at the nodal reactions, and now let's just give it a go. And we see some colors over here, and we get some idea that on the left faces the forces are significant compared to the other areas of the model, but we don't really know like where is the maximum force. So to find that, what we do is we go to edit and say find data. So we want to look in points, and you want to say you want to know where the magnitude of nodal reactions is maximum, and it's gonna run a selection query. And now we got a point, and as you can see it's marked over here. So right in the center of this red patch is the point where we get our maximum nodal reactions. So it's 5203, and these values are insignificant, so it's mostly along the x direction. So this is the way we can get max min values anywhere in the model. It's very comprehensive search tool, so we can create our custom scripts over here and then run the selection query. From here we go to query, and we can put in Python functionality as well. Okay, alright, let's just get out of it. One thing for sure, we can note that it is quite dim over here, so we can enhance the visibility by going to ambient and just kicking up this value. Okay, so I think that's too much. Alright, okay, what else we can do? So we know that the maximum force is on the left face, so why don't we just focus on the left face? And it's quite simple to do that as well. Okay, let's just show me before that one more feature, which is called opacity mapping. And if I check over here, enable opacity mapping, the whole body is turned into a transparent part, and only the areas with the maximum stresses are being colored. So we can see that if I go to my XZ view, the face near the left side and the cells around it are having the maximum stresses, and there are some stresses on the bottom as well. Okay, so this is also a nice visualization tip, and surely enough we can vary the color maps over here. So maybe this one according to our requirement. There are a ton of functionality available here to very minutely and accurately change the color graphs. We can also plot contours over here. So if I uncheck this one, okay, let's choose another one. There used to be a rainbow. Yeah, this is okay. So the most of model turned blue. Okay, now what can we do here? Yeah, we go to the discretization and change the number of colors to, let's say, 10. Okay, so now we see our contours, and the colors indicate specific ranges in which the result is falling, so the magnitude of nodal reactions. And it's quite it feels quite right, because you see the gradient is varying from the most intense color all the way to the other side of spectrum, which is the blue one. So okay, so now let's extract this left face. We want to focus more on it, and the way to do it is we go to filters and we're going to search for extract group. Okay, so these are all the named groups that I created in Salome before solving this model, and all of them surely enough translate into Paraview. And what we want to look for is BC5 left. So it's here. Let's just click apply, and there you go. Only the face on the left is kept and all other geometry is turned off, and it's again dark, so I'll just increase the ambience over here. Yeah, wait. Okay, now what we want to see is we want to calculate torque over all this entire face, and to calculate torque we have a formula that is r cross f. So the position vector of some point, that is my r, and the force that is acting over here, so my torque is equal to cross product of r and f. Okay, uh, how do we get to calculate it? So what we do is uh, first let's just visualize the nodal reactions, which way they are going, how they are oriented in the space. And to do that is simple enough. We go to filters and search for a filter called glyph, and select glyph. Now here in the arrays, okay, orientation array, we select nodal reactions, and let's just click apply. Okay, so now I see my nodal reactions at every point of the face. I can choose a solid color and maybe a smaller scale factor. Alright, so I see that the forces are acting along the positive x on the bottom side and on the negative x as we go up. Okay, so also we need a coordinate system to get a position vector of each point, and Paraview by default doesn't display the original coordinate system. It is a default coordinate system, but we can put it over here by including this command called axis. So let's just click apply. Alright, so we see a triad appearing over here, and this is the default global coordinate system. This is the default coordinate system that was used to solve this model. Maybe we can enhance its width, something along those lines, and it gets a bit thicker. Okay, so I want to see the bounds of my geometry also, and to do that I'll go to glyph. I'll go to the extract group and say data access grids. Now you see all my axes are marked. So this is my y-axis, and it's along the triad y-axis as well, and it starts at minus 0.02 and goes till minus 0.42. minus 4.2. Similarly for my z-axis, so my coordinate system is sitting right at the bottom of the face and height of 0.3, and same for x. In fact, there is no value along x because it's all along the yz plane. So that's one part of this. Now this is my nodal reactions. Of course, I can see them updating through the entire simulation. If I go back to my start, and it's oriented in this way, but the values are very less, so it doesn't matter. So you can see the values getting updated, and as well as the orientation. I can just change the color over here also to set block color. Choose sand. Okay, it's good. So okay, so that is my nodal reactions. Now I want to visualize all the uh, position vectors of all points on this face. So I'll select my extract group and I'll create one more glyph, and now this time we wanna, okay, we haven't still calculated a position vector, so let's just delete this one, and we're gonna apply a filter, and this filter is called location vector, let's say. And what we want to get out of it, we want to get the position vector of all the points, and in here the the part where we enter values, I'm going to select vectors and select codes. So actually Paraview has already calculated coordinates for us, so just click apply. So it has calculated my vectors, but they are not visible because I need to put a glyph over here. So filters, I'm going to select glyph, and here in my orientation area you see location vector, and let's just click apply. And of course we just want to visualize them without colors, and maybe reduce our scale as well to say 0.1. okay, so if I turn off my nodal reactions, you see that's emanating from the center point over here, that is 0 0 0. My position vector of each point is displayed as a vector over here for all the points. So along the negative y-axis, they are directed along the negative y-axis. Okay, and the change orientation with the point. So that's how we get the position vectors. And now it's time to calculate the torque. So for each point we want to calculate cross product of position vector and this nodal reaction forces. And what we now do is select this one and again put a calculator, and the calculator is going to be I'll call it torque. Okay, so vectors, first we need to input a command, so that is cross with parenthesis, and the first component of my cross product will be the code location vector, comma, and the second one will be the nodal reactions, and I'll just click apply over here. and it has got me a torque. So now let's visualize my torque vector at each point, and again I'll use a glyph filter for that. This time my orientation array will be torque, and I might just keep it low, right? And of course we want to put a solid coloring. All right, now you see the torque at each point. Maybe I should reduce my scale factor still more. Okay, so let's focus on this point, my first point. So this is my position vector. Just change their color. Okay, yeah, so the pink is the position vector, and this white arrow now is my I don't know, let's say purple. Okay, now my nodal reaction is along minus x. So if I look down here, so r cross f, this is my r and this is my f. So if I applied my right hand thumb rule like this, so my position vector should be my torque vector should be along this this direction that I just drew. And let's just clear the screen. Okay, and surely enough, you see here, let's unhide a few. Okay, this is my position vector, and this is my, okay, so there you see this, the first one, that is along the direction we just drew with the marker. And so we get all the torque vectors at each and every point on this face. But the issue, and sure, we can view them in a spreadsheet as well. If I open up another window here and click the spreadsheet view, so you see all my values. If I change this to calculator, okay, glyph 2, so my location vector is there, my nodal force is there, nodal reaction is there, and to find my torque, yeah, so here we get the torque at each point. One thing also we can use is if I just uncheck my glyph 3 and wanna look at wanna find out correlation between some point over here and the corresponding value over here. I want to see those values, so just go over here and I'm gonna say I want interactively selected points. So now if I click anywhere and choose to display only the selected elements, you see that my torque value is displayed over here for that point only. And to further help my selection process, I can just go ahead and turn on all these values, so ID would be helpful. So yeah, 395 is this is my torque. So I can also just turn off unwanted columns there. So that is my torque along Y and Z that are dominant over here, and I can just keep selecting and the results will be updated. Okay, so that's fine. How now we wanna see the entire sum of all the torques acting on this face. I want to see the sum of all the values along their corresponding axis x, y, z. How do I go about doing this? So first we need to clear selection, and what we need is let's just first improve my visibility again. Okay, what we need is a filter called integrate variables. So I'm going to search for it. So integrate variables, just select this one and let's just say apply. Okay, so it has integrated my torque over the entire face, and what we see is this value, that is my sum of all the torques, and that is very helpful to know. Okay, so surely enough I can animate this value as well. I can see my torque vectors changing as well. So it's really helpful, and I think this tutorial is helpful to you. Thanks for watching. Bye.